The velocity as a function of time of a car is given by the equation v is equal to 4 plus 0.25 times t squared. Plot the v versus t and a versus t graphs for the time interval t equals 0 to t equals 8 seconds. Find the instantaneous acceleration at t equal to 0 and t equal to 6 seconds. The equation for the velocity of a car, as a function of time, is given by v is equal to 4 plus 0.25 times t squared. Recall that the instantaneous acceleration is equal to the first derivative of velocity with respect to time, which in this case is 0.50 times t. In part A, we make a plot of velocity versus time and acceleration versus time. In part B, we are asked to find the instantaneous acceleration of a car at t equals 0 seconds and t equals 6 seconds. To do that, we will substitute the value of t into our acceleration equation. At t equals 0 seconds, the acceleration is equal to 0.50 times 0, which is 0 meters per second squared. And similarly, at t equals 6 seconds, the acceleration is equal to 0.50 times 6, which is 3 meters per second squared. Consider a ball moving in a straight line, starting from the origin. Given below is the graph of the ball's velocity in centimeters, as a function of time. Find the ball's velocity at t equal to 3 seconds. What is its acceleration at 4 seconds, and 7 seconds? Draw graphs of its position and acceleration as a function of time. Calculate the distance that the ball moves during the first 5 seconds. In this example, we are given a plot of velocity versus time. From this graph, we can see that the equation of the line can be expressed as velocity, v, is equal to the velocity at time 0, plus the acceleration at time 0, times time. In part A, we are asked to find the velocity of the ball at 3 seconds. From the graph, we can see that, at t equals 3 seconds, v, is equal to 15 centimeters per second. In part B, we need to find the acceleration at 4 seconds, and 7 seconds. Acceleration is the slope of the velocity versus time graph. From the graph, we can see that velocity versus time is a straight line, which means that the slope of the graph, and therefore the acceleration, is constant. The acceleration is equal to the change in velocity over the time interval, which is equal to the velocity at time 7, minus the velocity at time 0, over the time interval 7 minus 0, which is equal to negative 5 minus 30 over 7 minus 0, which gives an acceleration of negative 5 centimeters per second squared, which is the same for all values of time. In part C, we are asked to plot the position of the ball versus time. To do this, we must know that velocity is the first derivative of displacement, and therefore the displacement, x, at any given time, is equal to the initial position, x at time 0, plus the integral from 0 to t, of v dt. Now substituting v0 plus a0 times t, for v, we get x is equal to x at time 0, plus the velocity at time 0 times t, plus 1/2 the acceleration times t squared. We are told that the initial position is at the origin, so we set x at time 0 to 0. Then x at time 1 is equal to 0. plus 30 times 1 plus 1/2 of negative 5 times 1 squared, which is equal to 27.5. Similarly, to get the other points, we substitute in the value for t. And we get, x at time 2 is equal to 50. X at time 3 is equal to 67.5. X at time 4 is equal to 80. X at time 5 is equal to 87.5. X at time 6 is equal to 90. And x at time 7 is equal to 87.5. Lastly, in part D, we'd like to calculate the distance traveled by the ball in the first 5 seconds. D is equal to x at time 5 minus x at time 0, which is equal to 87.5 minus 0, which is equal to 87.5 centimeters. The graph shows the velocity of a reckless driver with respect to time. He drives at a constant speed of 25 meters per second for 4 seconds, and then decelerate to 10 meters per second, in the next 2 seconds. He then accelerates to a speed of 35 meters per second in 2 seconds, and maintains the speed for 4 seconds. What is the distance covered by the driver in the first 12 seconds? We are given a graph of velocity versus time for a reckless driver. And we would like to find the total distance traveled by the driver, in 12 seconds. We will break the problem into 4 intervals. The first interval is from 0 to 4 seconds. The second interval is from 4 to 6 seconds. The third interval is from 6 to 8 seconds. And the last interval is from 8 to 12 seconds. For each interval we will calculate and plot the acceleration versus time, and displacement versus time. For the first interval, from 0 to 4 seconds, we are told that the velocity is constant at 25 meters per second, which means the acceleration is 0. The displacement equation is, x at time t1, is equal to x at time t0, plus the integral from t0 to t1 of v dt. Therefore x at time 4 is equal to, x at time 0, plus the velocity times t1 minus t0, which is equal to 0 plus 25 times 4 minus 0, which is equal to 100. The second interval is from 4 to 6 seconds. We are told that the velocity for this interval is a straight line from 25 to 10. Therefore v is equal to v1, plus a times t minus t1. The acceleration, a, is equal to the change in velocity over the time interval, which is equal to v2 minus v1, over t2 minus t1, which is equal to 10 minus 25 over 6 minus 4, which is equal to minus 15 over 2, or negative 7.5. The displacement equation, x at time t2, is equal to x at time t1, plus the integral from t1 to t2, of v dt. So we have x at time 6, is equal to x at time 4, plus v1 times t2 minus t1, plus 1/2 a, times t2 minus t1 squared. This is equal to 100 plus 25 times 6 minus 4 plus 1/2, negative 7.5 times 6 minus 4 squared, which is equal to 135. For the third interval, the time is from 6 to 8 seconds. The velocity is a straight line from 10 to 35. which means that the velocity equation, v is equal to v2 plus a times t minus t2. The acceleration, a, is equal to v3 minus v2, over t3 minus t2, which is equal to 35 minus 10 over 8 minus 6, which is equal to 25 over 2, which is equal to 12.5. The displacement equation, x at time t3, is equal to x at time t2, plus the integral from t2 to t3, of v dt. So x at time 8, is equal to x at time 6, plus v2 times t3 minus t2, plus 1/2 a, times t3 minus t2 squared, which is equal to 135 plus 10 times 8 minus 6 plus 1/2, 12.5 times 8 minus 6 squared, which is equal to 180. Finally, the fourth interval is from 8 seconds to 12 seconds. The velocity is constant at 35, which means the acceleration is 0. The displacement x at time t4, is equal to x at time t3, plus the integral from t3 to t4, of v dt. So x at time 12, is equal to x at time 8, plus v3 times t4 minus t3, which is equal to 180 plus 35 times 12 minus 8, which is equal to 320. So therefore the total distance traveled in the first 12 seconds is 320 meters. Figure shows the graph of positions of a rabbit and a turtle along the x-axis. The rabbit gives the turtle a head start of 50 meters, in the 120 meters race. When will the rabbit and the turtle have the same position? Who reaches the 100 meters mark first? At what time, if any, does the rabbit pass the turtle? At what time, if any, does the turtle pass the rabbit? Who wins the race? The two animals will have the same positions when the x versus t graphs intersect. This happens at t equal to 8.3 minutes, and at t equal to 12.5 minutes approximately. From the graph it can be seen that the rabbit covers 100 meters in 10 minutes, and the turtle covers the same distance in 12.5 minutes approximately. The rabbit passes the turtle when the former moves above the latter in the x versus t graph. This happens at t equal to 8.3 minutes approximately. The turtle passes the rabbit when the former moves above the latter in the x versus t graph. This happens at t equal to 12.5 minutes approximately. The turtle reaches the 120 meters mark first, and so it wins the race. The acceleration of a truck as a function of time is given by a is equal to 5 plus 2 times t, where a is the acceleration in meter per second square, and t is time in seconds. At time equals 1 second, the velocity of the truck is 10 meter per second. What is the truck's velocity at time equals 2 seconds? At time equals 1 second, its position is at 10 meters. What is its position at time equals 2 seconds? It's given that the acceleration of the truck is equal to 5 plus 2 times t. Velocity is calculated by integrating the acceleration equation. After integration, the velocity is found to be 5t plus t squared plus a constant, cv. To calculate the constant, CV, we use the values that were given. At time equals to 1 second, velocity is 10 meter per second. Using these values, the constant CV is evaluated to be 4. Hence, the equation for velocity as a function of time is v equals to 5t plus t squared plus 4. Plugging in the time value of 2 seconds into the velocity equation, we can calculate the velocity at that time to be equal to 18 meter per second. Here, we plot the velocity equation found versus time. Notice that at t0, the initial velocity is 4 meter per second. And that at t2, the velocity is 18 meter per second. It's determined from part A that the equation for velocity as a function of time is v equals to 5t plus t squared plus 4. Displacement or position of the truck is calculated by integrating the velocity equation. Integration of 5t plus t squared plus 4 gives displacement x equals to 5 times t squared over 2 plus t cubed over 3 plus 4 times t plus a constant cx. Using the values given at time 1 second, the integration constant cx is found to be 3.17. Hence, the equation for the displacement as a function of time is x equals to 5 times t squared over 2 plus t cubed over 3 plus 4 times t plus 3.17. At time 2 seconds, the position is evaluated to be 23.84 meter. Here, we plot the displacement equation found versus time. Notice that at t0, the initial position is 3.17 meter. And that at t2, the position is 23.84 meter.